In this video, we're going to talk about networking in Azure, kind of where networking started from and how it's moving forward, and how Azure really works with that in the future. So probably the first thing to look at is how networking worked in the past. Traditional networking has been normally been using a leased line between offices. What that means is if I have a building here, I don't know, draw some windows in here. If I have a building here and then over here I have in maybe another state or another country, another building, what I would do is I would call up the phone company and I would say, I need to talk from building 1 over to building 2. Can you help me out? And they would say, absolutely. We've already gone ahead and dug some cables underground. Some of those cables touch your building. Some of those cables touch the other building. What we could do is we could just go ahead and splice those together, and you can pay us a monthly fee in order to use that. That's referred to as a leased line. Now, back when this originally started with leased lines, it was literally phone lines that you would use, and it was really slow quality network connectivity. As time has gone by, the line quality has increased, and therefore the price has increased as well. But it's not all that uncommon to be spending, possibly $10,000 a month for 2 buildings to be able to talk to each other on a high-speed network. So lots of money in order for those guys to communicate together. The great thing about leased lines is, well, you're pretty much guaranteed a lot of things by having, hopefully that's how you spell guarantee. You are guaranteed a lot of things by having that leased line. You're guaranteed, well, uptime and availability. Because you guys, in theory, building number 1 and building number 2 are the only 2 buildings connected to that system, you are guaranteed that you are able to connect from point A to point B. Additionally, because only 2 cables are connected together, your routing is a whole lot easier. And then lastly, you're also guaranteed bandwidth or throughput. That's what it says, even though you can't read it. So you are guaranteed all this stuff by having the leased lines. The only problem with having these leased lines is this right here, the fact that it costs quite so much money in order to have this point-to-point connectivity. The second option is a VPN over the internet, and this is where prices start dropping like crazy. My connection to the internet at home is like $40 a month, and I get like 40 megabits per second. So that's a very inexpensive price for me to be able to connect to the internet. If this building over here has a similarly inexpensive connection, then I could use a VPN or a virtual private network to be able to securely connect my home. There we go, my home over the internet to that building. So inexpensive, so that's only a $1 sign for the internet connection. However, all of these guarantees like uptime and bandwidth, and I forgot, privacy, all of those guarantees kind of go out the window. Because I'm going across the internet, especially if you're on a shared medium such as cable modem like Comcast uses, that shared medium shares bandwidth with your neighbors. So if your neighbor is downloading the latest Marvel video off the internet, their download is going to slow down my bandwidth. So my guaranteed availability and bandwidth throughput is not there anymore. Additionally, because I'm going over the internet, my privacy isn't necessarily guaranteed anymore. I now have to encrypt all of my data and hope that my encryption is strong enough to beat anybody who's trying to get into my data. So less expensive, but not all the guarantees that are available out there. And there have been some hybrids between leased lines and VPNs. This is actually where things are going nowadays. You've heard of SDL software, SDN, software defined networking, where it actually uses a combination of leased and VPN connections. In fact, even multiple leased lines and multiple VPN connections in order to balance multiple types of data from one point to another using different media. So that's the traditional, that's the way where things came from. And for the most part, this leased line right here, from a business point of view, has been the preferred method and still kind of is the preferred method in a lot of scenarios. So moving forward, what we have available to us as we go into Azure is fairly similar. Let's see. We have a leased line type connectivity called ExpressRoute. Now, the way that this works, basically my building, my office building right here, Contoso, I already have a building right here and I already have an ISP that I'm connecting to. Now that ISP can get me to the internet, he can get me to, my other buildings, he can get me to my data center, he can get me to lots of different places. And what I can do is I can tell my ISP, hey, I want part of my network connection to you, like maybe a one gigabit connection of that to be dedicated to ExpressRoute, which connects me directly to Microsoft. Directly to Microsoft. This essentially at that point is my leased line. Leased line. The connection between my building and Microsoft, even though it goes through the ISP, is still considered private. I can run non-encrypted data between my physical building and Azure, and it is across this ExpressRoute, and it is secure. It's considered a point-to-point connection, and I don't have to worry about anybody else being in that environment. Along with that privacy, I also get all the other guarantees, such as uptime. Bandwidth. My bandwidth is still available for me. My privacy is there. And then the fact that I own that link, so I don't have to necessarily share with anybody else in my neighborhood. I can literally have anywhere from a 1 up to, I believe, 100 gig connection between my building, Contoso right here, and Azure. Great. So I've got lots of data I need to send between me and Azure and from Azure to me. And so I can just buy this ExpressRoute. It's a monthly price that I already can factor into my budget. I don't have to worry about if I'm uploading or downloading from Microsoft. It's just included in and it's all there. So there we go. That's my leased line replacement. It's kind of a hybrid between a leased line and just cloud services. This works really well if I have 1 or 2 or 3 large buildings that I know I want to connect to Azure, or at least in like a hub and spoke environment where my primary buildings, my main office is the one that is connected up to Microsoft. So ExpressRoute, it's pricey, absolutely, but it solves a lot of issues and guarantees my results. The second option is, well, just like in traditional environments, it is a VPN. With a VPN, we could do what's called a site-to-site connection. There's actually 2 options here. Site-to-site is the first one. Out here we have Azure. And in Azure, we set up this VPN gateway. And then over here is our main office, or possibly even branch office, or even a home office, such as in my home. And here I can set up a network device such as a Cisco or a Palo Alto or even a Windows server, and I can set up a site-to-site VPN. Now, the great thing about having a site-to-site VPN is here I can have multiple clients, multiple desktops, multiple servers, and they are all connected to that one VPN connection. I don't have to configure all of them with a VPN setup. I don't have to set up VPN credentials. I don't have to put passwords or software or configurations on any of them. I basically just have like a router somewhere here that is configured for the VPN. That VPN then goes through the internet up to the VPN gateway in Azure and gets me straight into the Azure environment. Now remember, this is going across the internet. Somebody else might be able to possibly see or inspect my traffic if my security is not strong enough, as well as they could negatively impact the performance of my environment by flooding that connection otherwise, or breaking some other router in the internet that I may or may not be aware of. So, site-to-site connectivity, option number 2. And then option number 3 would be a point-to-site connection, which is what you normally think of when you think VPN. When I think VPN, I think I have a client right here. He has a VPN software of some sort installed on his computer, and he VPNs into Azure. Next person has some VPN software or configuration, and they VPN into Azure. Another one, and I can have hundreds and hundreds or thousands of clients all VPN'd into Azure. Now here's the cool thing. We can actually combine all 3 of these methods together. We can combine ExpressRoute, we can use site-to-site, and we can use, and we can do point-to-site all at the same time. Maybe ExpressRoute. This is my main office, my home office, where most of my equipment is configured. I configure it with ExpressRoute. So we go over dedicated connections that have dedicated bandwidth and dedicated availability. Then I have some sort of a branch office that I can configure with site-to-site. Maybe there's only 10 people at this remote office. They still need to be able to access my resources in Azure, but they don't need a fully dedicated ExpressRoute connection. They're not super expensive, but that's more expense than I would necessarily want to spend on a 10 or 20 person office. And then lastly, point-to-site. Maybe somebody's working from home. Maybe somebody's a road warrior and traveling a whole lot, so I could set up their laptop or home computer with a point-to-site configuration. So this is how we connect to Azure, is one of these 3 options that allows our current corporate infrastructure to be able to access our virtual infrastructure out in Azure. So that's networking between your physical environments up to Azure. Beyond that, once we have our physical connection to Azure, now we can start talking about our network architecture. How do we design our environment? How do we separate one environment from another, one system from another in order to make sure that they communicate securely? And that's where we start coming up with network groups. This is an example of what's called a 3-tier architecture. Very briefly, a 3-tier architecture. In the back end, we have our data tier. Think Amazon. Amazon website. You're looking for a new pair of socks. All of the information on their socks and what you've purchased and their sock availability and so on, that is all stored in their databases in the data tier. In the front end, however, is the web tier. The web tier makes things look pretty. Obviously, when I'm looking for socks, me as the end user over here cannot go straight to the data tier. I can't start looking around through Amazon's database directly to see what kind of socks are available. Even if I could, it would be so overwhelming, I would never go back to Amazon. Back in the early days of the internet, I ran into several companies that looked like that. Most of those companies are no longer in business. Imagine that. So instead of going straight to the database, the end user goes to the web tier. The web tier presents some nice pretty page for me to be able to see, and then the web tier then talks to the data tier on my behalf. The tier in between here, the business tier, is where what's called business logic comes in play. For instance, on Amazon, because I have a .edu email account, I have an inexpensive Prime account. Therefore, I am a Prime member. The business tier is able to look at my account when I log in, see that I'm Prime, and then once I log in, it comes through here, it says I'm Prime and says, oh, free shipping. So even though when the socks come back from the database, it goes to the business tier, it tags free shipping on there and then goes up to the web tier, looks really pretty, and comes back to me and says, here's the socks that will fit you, and it is free for you to be shipped to. That's kind of what the business tier does. It allows me to throw in coupons, or to be able to throw in free shipping, or to be able to say, you know what, it's going to take me 5 days to get to you because you're out in the middle of nowhere, as opposed to 2 days if you were just down the street. That's where the business tier comes in, of trying to be able to determine this specialized logic that would be in our environment. Now, in a traditional environment, how I would work this, if somebody gave me these 3 tiers to be able to set up in a network infrastructure, what I would do is I would have, again, because things are fairly expensive in the physical world, is I would have, say, the internet out here. I would have a firewall, a single firewall. A single firewall, maybe a load balancer. It would go from the internet to the load balancer, and then I would have one single network connection, and off of that I would have my web servers. Let's say those are all my web servers. I'll just type W. I would then have my business logic servers, and I would have my database servers. Well, assume there's 2 database servers and 2 logic servers, or business logic servers there. So this is essentially how I would configure this. This network right here would probably be 10.1.1.0/24. Now, the great thing about this is really easy for me to be able to troubleshoot. Somebody comes in from the internet, they go through the firewall, They go through the firewall to the load balancer and then hit one of these 3 web servers. The web servers then talk to the business logic, and then the business logic talks to the database, and then everything goes back the other way around to respond back. It's really easy for me to see. I could put a laptop or some sort of a troubleshooting tool on this network and listen to all that traffic and see how everything works and debug any issues that might come along. The problem with this configuration, however, is when you start thinking from a hacker's point of view. Maybe a hacker is able, actually I don't want him there. A hacker is out here on the internet and he is able to come through and exploit this computer. So this web server right here is now owned by the hacker. The hacker at this point now has unlimited access to every single computer in my environment, at least in my web environment. From this point, the hacker can attack that machine or that machine or that machine or that. The hacker can attack every single machine in my environment. Why did I configure it this way? Well, mostly because this load balancer, choose a different color here. Mostly because this load balancer and this firewall are really, really expensive. I would love to have had more than one firewall in here, but those things are like $10,000 a piece. I would love to have had multiple load balancers in here, but those things are about $10,000 a piece. I just can't physically afford it until we go to Azure. In Azure, the load balancers are virtual. So I could put a load balancer here, I could put a load balancer here, and I could put a load balancer here. it really doesn't cost me as the as the consumer much, if anything. Okay, so the load balancers are free. What about the firewalls? Well, the firewalls essentially are free as well. This right here is what's called a network security group, or an NSG. Basically, this red box right here is a firewall. In order to get into this NSG or out of this NSG, it has to match a firewall rule. I then have another NSG right here in this gray box around the business tier. In order to get into the business tier, I have to match a firewall rule. What rule does it say? Well, it means that firewall rule says only from the web tier into the business tier on certain ports. Same thing for the data tier. There's another NSG. Only the business tier could talk to the data tier. So because all of this is virtual and in the internet, I can now just build out multiple virtual routers, multiple virtual firewalls and virtual load balancers on any desired or at any point that I might possibly need. So virtual networks, we can spin up as many virtual networks as we want. Thousands of virtual networks, all based on our need. Web tier, right there, you got one. Maybe you need a test web tier. Well, let's build out another virtual network for the test web tier. Maybe there's a dev web tier as well. Let's build out another virtual network for the dev web tier. The virtual networks and the network security groups don't cost me anything if I'm not using them. So let's build them out and just use them as we might possibly need to. There we go. One other example that we might have seen previously in last week, I believe it was last week, it might have been the week before, we talked about file storage. Storage in the environment, and specifically one of the things that we saw was a file storage. When we were talking about the file storage, we said that we can't necessarily publish this to the internet because it's insecure and most ISPs will block it. In fact, I did that as a demo and it blocked on me, and I was like, why isn't this working? And it's because file storage should not really be going across the internet. However, what I can do is I can say the data tier right here can access my file storage. So I can actually create another network security group or another virtual network and put the file storage in there, and then say the data tier or whichever other tier I might want can talk to my file storage network security group, and therefore they can communicate back and forth on an as needed basis. The cool thing about this entire environment, if you're not paying attention or if you're not necessarily seeing it, the only things connected to the internet is this right here, this load balancer, and possibly this management jump box, because the DevOps guy needs to be able to get into it. So the business tier, the data tier, none of those can access the internet. Only the internet can only access through this load balancer. The DevOps guy, maybe he's at the office, maybe he's at home. He logs into the jump box. Actually choose a different color here. DevOps guy logs into the jump box. From there, he can log in to all of these tiers in order to configure those. That way my Active Directory subnet never sees the internet. However, my DevOps person can still log in and manage it as necessary. Imagine that. Architecting things securely. It's a pain to try to figure all this out. What's a web tier? What's a data tier? What's a business tier? What other tiers might there be? How would we organize them? Who could talk to who? It's a pain to set it up. But once it's set up, it looks so amazingly pretty that you're just, there it is. It's working. Yay. All right. Yes. Okay, and then the last thing to talk about when we're talking about networking is load balancing. And I don't believe I have a slide for it. So let's see if I can find a picture. So along with networking, we've talked about load balancing to be able to load balance between multiple servers. That normally has been what's called local load balancing. Load balancing within the data center is the standard load balancing that we're probably all familiar with. There are no pictures talking about this. Beyond that, we also have what's called a regional load balancer. And the regional load balancer does just that. It load balances between regions. That's local. All right, there are no pictures for it. There we go. A regional load balancer basically is able to look at the data in an environment, or the data stream that might be in an environment, and balance that data between two different data centers. There we go. Where'd I go? So for instance, here we have a regional load balancer. Traffic manager. That's the right term I was looking for. The regional load balancer, or traffic manager as Azure calls it, basically looks at our two different regions. And it looks at the data coming in from a client, and it says, what region do you apply to? What rules should I apply to your data to be able to send you to either region 1, say West Coast of the US, or region 2, East Coast of the US. So maybe it's able to look to see, I'm in Washington State, so I'll send you to the West Coast. Or I'm in Florida, so I'm going to send you to the East Coast. Or maybe I have more than one region, more than two regions here, and somebody in Europe goes to the European data center, and so on. So Traffic Manager is able to inspect this traffic and apply rules based on the source of the client to be able to send them to the closest location. That way I can have one site, such as, Amazon.com. I probably shouldn't use them as an example here. Let's say maybe Microsoft.com. Therefore, I hit Microsoft.com, and the traffic manager says, you're in Washington. I'm going to send you to the Washington State or the Oregon State data center, and you'll get the closest Microsoft.com website there is. Interesting. So traffic managers able to help direct me around to the closest possible location. Above and beyond that, it's also able to inspect the destinations. Let's say region 1 goes offline for some reason. Maybe it's a planned outage. So maybe I'm doing some updates in the environment, or unplanned. Somebody broke something over here, and it broke our servers. Traffic Manager is able to inspect the fact that this link is no longer working, either intentionally or unintentionally, and force everybody over to the backup location. So the regional load balancing helps us to be able to separate out, one, optimize the traffic, and then two, make sure that everything is available at every single time. So there you go. That is the idea behind the load balancing and networks and virtual networks in Azure. That's a very brief introduction, but really that's kind of how I've always seen things, especially when talking about the history of networking, dealing with the traditional connectivity. There we go. With the leased lines between the offices. It still exists out there. There's still a reason why the phone companies still exist, is because people are paying for it and because it just works. VPN is becoming popular, but honestly, if I know that I'm going to need to send hundreds of megs or hundreds of gigs of data across the internet in a month, instead of a VPN, a leased line may be more appropriate. There we go. So this week in the labs, there are, I believe, quite a few labs specifically having to do with the site-to-site VPN, as well as the VPN gateway. They're pretty interesting. Good luck with them. Otherwise, have a good week.